Hi students, welcome to Chemistry online classes. In the previous class I discussed about the geometrical isomerism, the continuation part 1. See, this is one example for geometrical isomerism. This will show geometrical isomerism or not. Then three conditions we have to apply. What is the first one? Restricted rotation present or not. Second one, groups at the restricted rotation. Third one, relative distance. Restricted rotation present, double bond. Second one, groups at restricted rotation. H, CH is different. CH2, CH2 same. CH2, CH2 same. CH2 both bonds same. So left side same groups are there. Therefore, do not show geometrical isomerism. This will do not show geometrical isomerism. If I give like this, now it shows the geometrical isomerism. HCH3, here CH2, but here what is there? CH. CH. Different groups are there. So different group is there, it shows geometrical isomerism. This will show. I will write the only different molecule on this one only to understand which will show geometrical isomerism, which is not. Now if it is given like this, then it will show geometrical isomerism or not. This is different, HCS, but here same, then this is belongs for both, up and down, same is there. So this will do not show geometrical isomerism. Now I am removing this and placing double bond here. It will show or not done. This side what is there? CH. Here what is there? CH. Now if I place here, now CH shows or not? Yes, because here different is there or not? That we have to check. So how to check? First carbon same in second carbon same in third carbon. Like this we have to go alphabetical order how we are checking the nomenclature. Here also same. First is same in next is same in next. Like this we have to check. Got the concept now? H, CH3, Cl. This bond concept. Otherwise, this is direct bond only. It will show or not geometrical isomerism. Shows or not? Shows. Next, H, CH3. This will show or not? No. If here, yes. Got the concept? Next, HCH3. This will show or not? No. If here, yes. Getting concept? So like this, any given for you, then you have to decide that they show the geometrical isomerism or not based on the groups present at the restricted rotation. This is the geometrical isomerism shows by different molecules. In the last class also I discussed, and this is a few examples. Now, their properties. What are the properties are there? First one, stability. Take here 2-butene. 2-butene here, one is cis form, another is trans form. We know that same groups are similar side to the restricted rotation, that is cis form. Now it is cis form. Then another one, CH3, CH. This is trans form, this is cis form. Which is more stable, cis form more stable or trans form more stable? How to decide? If you go with the hyperconjugation is a functional group. Next carbon what is that? Alpha carbon, and alpha carbon hydrogens are alpha hydrogen. How many alpha hydrogens are there? Functional group next carbon alpha, functional group next carbon alpha. Alpha carbon hydrogens are alpha hydrogen. 3, 3, 6 hydrogen. Here also 3, 3, 6 hydrogen. These are not alpha. These are bonded to functional group. So total here also 6 is there. Here also 6 is there. Then how to decide? Both are equal number of alpha hydrogen. Alpha hydrogen equal to 6, alpha hydrogen equal to 6 based on the hyperconjugation. To decide here, this is bulky group, some steric repulsion will be there. Here, no repulsion, opposite direction. Therefore, which is stable form? Cis form or trans form? Trans form. This is more stable than the cis. Now, polarity. Polarity is related to which one? Mu. Dipole moment. Dipole moment equal to 0. Dipole moment equal to 0, that is called which one? Non-polar. Non-polar. Dipole moment not equal to 0, that is called polar. Okay. Now tell which is polar, which is non-polar. So this is vector quantity. Dipole moment is which one? Vector quantity. We know that dipole moment formula what is that? Mu equal to Q into L. Charge into length. Or R also given in some books, D also given in some books. Okay. So now methyl group is donor group. Yes sir? So it will, its vector quantity towards the carbon. Here also towards the carbon. Hydrogen not that much donor group or withdrawing group. So with respect to CH only it represented. Here this will be towards the carbon, this will be towards the carbon. Then mutual cancellation is there or not? Then which will having the more dipole moment, which is having the less dipole moment? Cis having the more, because resultant vector quantity in one direction. Therefore, cis having the just I am writing here mu. Mu is cis form is greater than the trans form. Cis is greater than the trans. Then you may ask the question: is always conditional? It depends upon the group. See, cis form having the more dipole moment than the trans form. Got the concept? But always it is true? No, because it depends upon the groups. Here methyl group is there. Now, if you consider this is Cl and CH3, here H, here H. Which form this is? Which form this is? Hydrogen same side. Then cis form this is. Then this is cis form. Now this is Cl, this is H, double bond H, CH3. This is which form? Trans form. Carefully observe. Methyl group is donor towards the carbon. Chlorine is more electronegative than the carbon. Then it withdraws. One is up, another is down. Somewhat mutual cancel, not 100% cancel, little bit or 50%, 60%, whatever. Not 100% mutually cancel. Only some percentage is mutually cancel. Here, this is chlorine is withdrawing, it is donor. Then resultant, which one having the more dipole moment? Trans form. So we cannot tell here cis having the more dipole moment, trans having the more dipole moment. It depends on the its group. But generalized statement, generally which one having cis is more than the trans. But always not true. It depends on the groups. So you decide based on the group, and you should know that the vector quantity also which is having more dipole moment is having less dipole moment. So now here which form having the mu more, cis having the less, and trans having the more. So don't decide blindly cis more than the trans. It depends on the group. Repeatedly I am telling this. Now, next one, boiling point. Next one term is boiling point. I am discussing with respect to this one only. Cis 2-butene, trans 2-butene only I am considering. This is just one more example I give. So with respect to here, stability, cis is less stable, trans is more stable. Dipole moment here, cis is greater than the trans. Now boiling point of this molecule I am discussing. So boiling point depends on the polarity, keep in mind. Otherwise not in stable. Boiling point depends on which one? Polarity. More polar, more boiling point. Directly proportional, right? Polarity directly proportional to boiling point, or boiling point directly proportional to polarity. Boiling point directly proportional to polarity. So which is more polar here? Cis form more polar or trans form more polar? Cis form. Then which is having more boiling point? Cis form. Therefore, boiling point cis is greater than trans. Why it is cis meaning here? Boiling point is directly proportional to which one? Polarity. Clear? The next one is melting point. Now tell, melting point also depends on the polarity? No, it depends on which one? You may be studying the solid state chapter also. Melting point of molecular crystalline solid and covalent crystalline solid. Another one which one? Metallic crystalline solid. All this studied. In that which is having the more melting point? Molecular, next ionic, another covalent. Which one? Another metallic is it? Among these four, which is having the more melting point? This question asked, it means some four examples are given. Silicon, another one is ammonia, another one is NaCl. Like this, four compounds are given in 2013 JEE mains question, which is having the more boiling point or melting point. Like this question they asked. Then how to decide? Now take wood and stove. It is in front of you only. So which is easily burned? Wood. Stone. Then how you are deciding this is? It means stone means they are very closely packed. Wood loosely packed. Yes or no? Some gaps you can observe. But here this stone is completely packed. So the melting point is depends on its packing efficiency. More closely packed, more melting point. Less closely packed, less melting point. Then cis form is more closely packed or trans form is more closely packed. Now see, that is only I want to show you here. This is the cis form. Yes or no? This is only represented in the bond line structure. Now, like this is form. Transform observe. Which is closely packed? Trans. Then trans closely packed, there's a boiling melting point. Trans is greater than cis. These are the general points or their properties. For solubility also you can check solubility also. Now, water is polar solvent or non-polar solvent? Polar solvent. Then you know that like dissolves like. What is the meaning of like dissolves like? Polar compound soluble in polar solvent, non-polar soluble in non-polar. Opposite solubility less. Polar soluble in non-polar less, non-polar soluble in polar is less. Maybe little bit but not completely soluble. So solubility now, which is polar? Cis is polar or trans is polar? Cis. Then which is having little bit solubility? Cis form is more soluble or trans form more soluble? Polar soluble in polar soluble. Now the question, you may got the question here. So you not mention in water or in any other solvent. Then already you may be studied in the alcohol chapter or oleate ketone. Unless until mentioned, the solvent is which one? Water. So not mentioned in what you have to think? Water only. So solubility always discussing with respect to which one? Water. When the solvent is not mentioned, if they mention non-polar solvent, that non-polar solvent respect to you have to think. Now I am not mentioning what is the solvent? Water. So solubility here they given me compulsory that solubility our discussion with respect to which one? Water. Then which is more soluble, which is less soluble? Cis form is more soluble than the trans form. So cis, then trans. Clear? So these are the some general properties. Generally these are asking up to CET level to up to Neet level JEE mains also. You have to remember. But students are generally confused here only. Where? In the polarity. Another one, melting point. Because melting point is depends on which one? Packing fraction or packing efficiency. You correlated with the solid state. Okay. Now, EZ nomenclature. Already discussed in the oligonucleotide chapter, but once again just revising that concept. Cis and trans, when we are discussing similar groups are same side, cis similar groups of opposite direction, that is trans. Then when we have to use the EZ nomenclature, then only I can give the simplest form. When we have to use this EZ means at this double bonded carbon, at least one hydrogen or no hydrogen is present, that time we have to use the EZ nomenclature. When we are using the EZ nomenclature, one hydrogen at least, not at least, one only. One hydrogen only present or no hydrogen present. One hydrogen present or no hydrogens are present. That time only we are using EZ. If two hydrogens are present, no need to use. We can use also, but cis and trans form is available. Further concept. So now I am giving here like this. A double bonded carbon. These are double bonded carbon. How many hydrogens are present? Carbon value is how much? 1, 2, 3. Then here what is it? Hydrogen. 1, 2. Here CH3. Here F. So here no hydrogen. So one hydrogen or no hydrogens are present. That time we can use the EZ nomenclature. This is the first condition. Condition 1. Second one. Divide this molecule into like only in mind, don't do in paper. This dotted line in mind only have to do. Two halves are there. Left side half, right side half. Then third one, give the priority. Give the priority to this groups bonded to double bond or any distinct double bonded carbon, double bonded carbon. Then how to give the priority? Fourth one. Priority order, right? I am ready. Priority order. Higher atomic number is first priority, lower atomic number is least priority. So that is what I am writing here. Bromine, next chlorine, next sulfur. This is atomic number 35. Atomic number 35, 17, 16. After this, fluorine, how much? 9. After this, oxygen 8. Then nitrogen 7. Carbon 6. Next, in this isotopes are present. If it is isotopes are present, then what you have to do? C14 and C30. Then C12. Then next, if you go for hydrogen, hydrogen is tritium. Atomic number what is that? 1. But atomic mass how much? 3. Otherwise you can write this is like so tritium is first priority, then the deuterium is first priority, then the hydrogen. So this way we have to follow. I give just few examples in this order, not all mixed here. Because not only these are the elements, no, total how many elements are there? So many elements are there. In that which is frequently used in this EZ nomenclature, that is only represented. Got the concept? Second one. Here this is in priority. This is the one small letter. This is another one pencil. This is. So second one. If double bond is there, double bond. See, this can be represented as, how to think this is? Otherwise, CH2, this is like this given. This is a bond. CH double bond CH. If it is given, how to think this is? Assume that bond, carbon, carbon, hydrogen, hydrogen. How many bonds are there here? 2 bonds. Then one bond only represented. One bond only represented. One. Next, what is it here? Carbon, carbon is here. How many hydrogens are there? 1, 2. Got the concept? Here one more bond is there. That one more bond, what you have to think here? Another type carbon. This carbon bonded with the how many carbons are? 2 carbon we have to accept. Because this bond one, this bond another one. Clear this? Carbon valence is satisfied, of course. Next. Here carbon is satisfied? No. Then this carbon bonded with the how many hydrogen? And one carbon, another bond with another carbon. Reverse you have to think. This is forward you have to think, again backward. Then here again. Got the concept? If you are not understanding, one more I will give. Tell. How to assume this? Bond, carbon, carbon. First single bond, one hydrogen. Now carbon valence satisfied? No. So remaining how many bonds are there? 2 bonds. Then one bond carbon, one bond carbon. Now reverse. Carbon, hydrogen, one carbon. Remaining how many carbons are there? 1, 2. Clear this is? Then go for next. What is the meaning of this? Aldehyde. Aldehyde, how we are writing this is CH double bond bonus. Actually, that is only structure. But how to assume this is? How to assume that? Carbon, hydrogen, single bond, oxygen. Now here don't confuse. Here only the confusion starts. This carbon with how many bonds now? 3. Then first bond oxygen, second bond oxygen. Oxygen having how many bonds? 2. One already given. Then second one, what is it? Down or upright? Don't think anyone. Only up or also correct, down also correct. This side also correct. No problem. Then what you have to write? Carbon you have to write, oxygen you have to write. Question C. What I told here, left side carbon for right side how many atoms are there? For right side atom, left side which is there. Then what you have to write? Carbon you have to write. Clear? Because oxygen bonded with the carbon. Clear this is now? Next. Like anything is, you have to think like this one. Now this is given. Tell, assume and tell. Single bond carbon, single bond nitrogen. Now, how many times this carbon bonded with the nitrogen? One already completed. Second, third. Next, nitrogen. Nitrogen one bond is completed. Remaining bond is what you have to write? Nitrogen carbon. Carbon. Next, nitrogen valence also you have to think. 3 or 4? 3. 3 is there or no? Clear this is? Now, one more example. Which is first priority in this? Now, sorry, given this is order, but this order how to assume? Got the concept? Which is first priority group here? Then what you have to think? This is we know how to assume. Got the concept? Then this is meaning what is that? Bond, carbon, CH3, CH3, CH3. So its meaning already represented here. C, 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 H. Then bond, bond. Carbon, carbon, same. Carbon, carbon, same. Carbon, carbon, same. Carbon, carbon, same. But here what is there? Hydrogen. How many are there? But here what is there? One hydrogen, two carbons are there. Then carbon atomic number greater or hydrogen atomic number greater? Then which is first priority? This is first priority, this is first priority. First one is first priority because carbons are there. You got the concept there? So priority are this. Clear this is it? Next one more will take. Now, this is we know. Then one carbon, second carbon, third carbon. Then this third carbon. This is bonded to 1, 2, 3. Clear this is? Then this will be CH3, CH3, CH3. Correct? Carbon, carbon same, carbon, carbon, carbon same. Then here what is there? Carbon. Here what is there? Carbon. Correct? One line is carbon. Then here what is there? That is like, okay? So anyway, this is only the first pair. This is only the first pair. So based on that, we will discuss one example. Then double bond. Is there a one? Now I will give here in one, and here like this. Tell this double bond in which form? E form or Z? Already you know, that's why I got written here E and Z. E mean what is that? E mean and it means opposite. Same priority group should be opposite. Z meaning what is that? Zusammen. Its meaning what is it? Together. Its meaning what is it? Together. So we are giving this togetherness or opposite with respect to first priority. First priority groups are opposite, that is called E form. If first priority groups are same sign, that is called Z. So for easy remembering purpose, also one more trick I am giving here. This is called Zane. Zane means what is that? Like same. Antagonist means what is that? Opposite. Correct? Opposite to opposite. It means opposite type. For easy remembering purpose. Clear this is? Now tell, this is a double bond. This carbon, here also what is there? Carbon. But here how many hydrogens are there? 3. Here how many hydrogens are there? 2. 2 hydrogen same. Another hydrogen is there. But here what is there? Carbon. Then which is first priority? Our rule is first one. This is at least one hydrogen is present. Then we have to start the EZ non-EZ. Then in mind only half this side. Then there is half. Then left side I am giving the priority. Which is first priority? Up or down? Up. Then this is the first priority. This is second. Right side half. Here what is there? Hydrogen. Here what is there? Carbon. Carbon first priority or hydrogen first priority? Carbon. Then this is first priority. This is second priority. Nothing is there. You have to think hydrogen. Okay. First priority groups are which side? Same side. Same side means what is that? Same. Same means this is Z form. This is middle left side group, right side group, this side. Here nothing is there means what is that? Hydrogen. Hydrogen atomic number 1, carbon atomic number 6. Then this will be the first priority, this will be the second priority. Here carbon, here chlorine. This which form? Which is first priority? Chlorine first priority. Because atomic number 7. This is 1. This is second. Now first priority groups are opposite. Then it is which one? Opposite. E form.